In today's video, I'm showing off how I made this space scene in OpenGL and C++. So as you can see, we can fly around, and we are surrounded by a space background with some nebulas. And if we look at the scene, we have about 2,000 of these asteroids located around the scene. And then in the center, we have this big planet. And if we look at over here, we have a settings, and we have two settings we can turn on. So the first is normal lines, which will draw these yellow lines from all the normal points on this model of the planet. And then the other one we have is explode, which will take all of the vertices of each asteroid and the planet and expand them and then contract them back to their original position over time. And you can see it creates this cool looking effect here. Alright, so if we look at the source code for how this works, what we have is, first thing we do is to create a skybox, which is the space background around the scene. So what we do for that is we have a skybox vertices, which is an array of floats, and then we create a VAO and a VBO with it. Then after that, we create a vector of strings that stores 6 textures, one for each side of a box, and these correlate to PNG images, which show space and nebulas and the stuff you see in the scene. And then we create a cube texture and load that, and then set it to our skybox. And the way we load a cube texture is very similar to the way we load a regular texture. However, we use GL texture cube map instead of GL texture 2D, like up here. And when we actually load the texture, we run a for loop that iterates through each texture and loads it to a different part of the cube map. And then down here, we draw in, or we load 2 models. We load a rock model and a planet model. And then we set an amount of asteroids equal to 2,000. We dynamically allocate memory for an array of 40 matrices equal to the amount. Then we generate a seed for a random number using getTime. We set a radius and offset, and that determines how wide and how far apart the asteroids are. And then we run a for loop setting each of the asteroids' model transforms based on a number of details. So angle is determined by what place in the for loop you're at, which is I, divided by amount times 360. The scale is just sort of randomized, but it's between 0.05 and 0.25. So in short, this basically just creates a giant array of mat4s, which each are a model mat4 for an asteroid. And then down here we create a matrix VBO, which is just a regular array buffer. Its size is equal to amount times size of GLM mat4, and we put the model matrices data in here, and then we run this for loop, and for each of the rock's meshes, we get its vertex array object, we bind it, and then we set up vertex to trip pointer, so there's 4 spots, which means it can hold 4 vectors, which is the same as a mat4. Alright, and then in the render loop, we use our shader, we calculate the lights, and then we do the model math and draw in our planet. After that, we use our instance shader, and for each of the rock meshes, we bind that rock mesh's VAO, and then we draw elements instanced. And when we draw elements instanced, it's similar to drawing arrays normally, but we go GL triangles, the size of the indices, unsigned int, 0, and then the amount. So instead of drawing each of the 2,000 asteroids with their own draw call, we instead draw all of the asteroids at once, and we just iterate through all their meshes. So there's way fewer draw calls, but we still are able to create thousands of objects, and that is how we do that without it lagging a ton. And then after that, we set up our skybox shader. We skybox shader use. We set the depth function equal to GL less than equal to. and then we draw in the skybox using that cube map we set up. And then down here we have the GUI settings, which we covered in the last video, but this just allows us to pick none, normal lines, or explode. And then to explain how those work, if we go back up to our shaders, our normal shader, our instance shader, and our normal shader all have this .gs file, which is a geometry shader, and it's a third type of shader that you can attach on. And what they do is they generate extra points or extra vertices for whatever's being drawn. So what the normal geometry shader does, and this is the one that creates those yellow normal lines, is it takes in triangles and it spits out 6 vertices in line format. So we'll create 3 lines, each with 2 vertices. And then what we do is to generate a line, we grab the position where the triangle would normally be, and then we create a second one, which is that position right here, plus the normal times the magnitude. And then we draw 3 lines. And if we go to our point geo, which is the one that lets us do the explode function, what we do is we have this function called explode, and if time is equal to -1, which is when we're not using the explode feature, we just return the position. Otherwise, we calculate a direction, which is equal to normal times the sine of time plus 1, and then we return position plus direction. And then down here, what we're doing is for each of the 3 vertices, we get the position equal to explode, we set the text chords equal to text chords, normal to normal, frag to frag, and then we emit it. And if we go into our vertex shader, we output those 3 values into the geo shader, and then that goes to the fragment shader. And we also have this feature, which is not related to the geometry shader, but is something else we're doing in the shaders, which is this layout std140 and then uniform matrix. And what this lets us do is, in our code, we only have to ever update this. We only have to update this matrix once, and we do it right here. But this is the same code which is in the instance vertex shader right here. And what that means is that we don't have to set the uniform values twice. It's standardized across the entire program. And then finally, to determine whether we will actually use the normal and the explode feature, we have this integer called GUI effects, which starts at 0, and through GUI we can update it to 1 or 2. If we update it to 2, we set the time equal to GL get time for both the shader and the instance shader. Otherwise, we set time equal to -1, which means the other file just returns the position. And then down here, if GUI effect is equal to 1, we draw the planet again, but we use the normal shader, and we set these 3 values, which means that on top of the planet, we also get all those lines. But if you're curious on how we use the GUI effects and what other effects you can use if you have a GUI interface, you should click on this video here where I show exactly that. And until next time, see ya.